countdown.
مبروك، يتم تقديم هذا البث مباشر لكم خصيصا من قبل أكاديمي يوتيوب ماليزيا، مبادرة إيديدي ماليزيا وكلاب كرو ماليزيا. ركزوا انتباهكم، سيبدأ البث مباشر بعد القليل. سيتم رابط الحضور في نهاية البرنامج. الرجاء على ملء الرابط في وقت محدد. شكرا لكم. لقد تم توفير هذا الإعلان من أكاديمي يوتيوبر.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD and a Club Guru Malaysia. Bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Umul Kitab Al-Fatihah. And for the non-Muslim, please recite your prayers according to your religion. Okay, how is everyone doing today? My prayer that everyone is in the best of health and ready to proceed with today's class. Let me introduce myself first. I am Madam Rosmaya as your moderator for today. I'm a Form 6 Physics teacher at SMJK Yuhua Kajang Selangor. And together with us is Teacher Im, our host controller, okay, from College Tingkatan 6 Tapah Perak. And our observer is Teacher Fatia, okay. Teacher Fatia from Pusat Tingkatan 6 SMK Seri Serdang Selangor. Their job is to ensure our today's session running smoothly. Okay, and the most important person today is our presenter, teacher Zana. She is a very experienced retired teacher from SMK Tunku Ampuan Durrah Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, for the record, okay, we are now live on Teacher Zanariah channel. So as a sign to support Teacher Zanariah for the hard work in preparing today's lesson, please subscribe to her channel. Not forgetting also to subscribe Teacher Im and Teacher Fatia channel. Okay, as usual, the lesson will last approximately 1 hour. Okay, the certificate link and the credit claim link will be given at the end of the session. And remember that you can only use EDD email to claim the certificate. And more account also can, right? Okay, remember that you can only use EDD email to claim the that one. Okay, and if more account. Okay, for the credit claim, you need to collect the 1 letter, okay, and a 4-digit codes, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. Okay, stay focused, and if you have any questions, please write on the chat box and Teacher Zanaria will try to provide you with the answers. And before I give to Teacher Zanaria, okay, to present, I announce the first digit code, okay, with a letter for credit claim. So the digit is A4, okay, A4. Okay. So without further ado, please welcome Teacher Zanaria to start her presentation.
Okay, thank you Madam Rosmaya. Alright. Assalamualaikum warahmatullahi wabarakatuh. Thank you to all the amazing students for joining today's class. Thank you to Teacher Im, Madam Rosmaya and Cikgu Fatia for helping out to ensure the smooth running of today's class. I am Cikgu Zana. As introduced by Madam Rosmaya, I'm already retired and my last school was in SMK Tunku Ampuan Durrah Seremban. You can subscribe to my channel by scanning the QR code. Okay, Students, allow me for a few couple of minutes to introduce my fellow teammates in IU in the pre-U lesson collaboration. Okay, firstly, we have the chemistry team led by Cikgu Shannon. Next, followed by biology, and we have teacher Fatia with us here. Cikgu Fatia is the second from the right. And we have the physics team. Madam Rosmaya is on top. Madam Rosmaya is our moderator for today. And also we have the account and economy team led by Madam Fizi. And last but not least, the mathematics team led by Teacher Im. Okay, right. For your information, you can get the link to the playlist in the video description given below. Okay, please check out the video description for the link. And for the exercise link, please check out in the chat box. Okay, today's lesson will be on functions, and we'll be looking at composite and inverse function. Okay, students are required to acquire these 4 skills in order to answer the composition and inverse function. So what are the 4 skills? So the first skill is that students must be able to identify or to able to understand the existence of these 2 functions. And the second skill is that they must be able to find the restricted domain for the composite and inverse function to exist. And of course, they must know how to find the composite and inverse function with their domain and range. And lastly, they might ask you to graph the composite and inverse function. So if you are able to acquire these 4 skills, you have no problem answering composite and inverse function. Okay, let's not waste any more time. Let's go to definition of composite function. So to understand the composition of this function, let us use this Venn diagram. So consider these 3 sets, okay? A, B, and C. The first function f maps x in A to f of x in B. In other words, the input of f is x, the output of f is f of x. Then we have the second function g. This function g would operate on f of x. F of x becomes the input of g. Hence, the range becomes gf of x, thus forming gf of x. So the composite function g of x is described as the mapping in the element in set A to the element in set C. So, and it's denoted as g of fx, or in formula form gf of x for all x in domain f. Okay, in other words, g of fx is created by substituting f of x in gx. And the existence for g of f to exist is that the range of f must be a subset or equal set to domain G. So this is the condition for g of f to exist. So students must know this. It so happen I'm using example g of f. It might be f of g, okay? So just remember the range of the first function must be a subset or equal set with the domain of the second function. But take note, okay, this is the condition. Okay, take note that domain G of f, okay, is either the same as domain f, okay, it's the same as domain f, or else lies inside it. So lies inside it means a subset. It can be equal or it can lies inside it. And the range G of f can be equal to range of G or lies inside it, okay. Later on, when doing the exercise, you understand why sometimes the domain of GF lies in GF and range of GF lies in range of G. Okay, senang nak ingat ya? Senang nak ingat saja. Okay, this is the first function, so the domain must follow the first function. This is a second function, so the range must follow the second function. Now, what about the inverse function? So in the most general sense, when we say inverse, so the functions reverse each other. Okay, the function reverse each other. So it reverses the input and output. Okay, consider here, we have the element in the first set in domain. and the function f maps x into y. So while the f inverse, it reverse. The output become the input become the output. Okay, that's why it says the inverse is just reversing each other. So from here we can say that the domain of, this is the function notation, the inverse function notation. This is the definition actually, that f of x equal y, hence the inverse of fy is x. Okay, so from here we can see that the domain of the inverse function is actually the range of f. The range of the inverse function is actually the domain of f. Hence, we can say that domain of the inverse function is range of f, and range of the inverse function is domain f. Now, the inverse function can only have an inverse if the function is one-to-one and onto function. So this is the condition for a function to have an inverse. So you must know what is one-to-one, students, okay? And onto, I think your teacher has explained this in class, okay? Next. One-to-one you have learned in Form 5, okay? Right, take note, okay? This is called the additive function, okay? Or we say composite function, f of inverse fx is x. What does this imply? It implies that first the function f maps x to y, and the inverse function f maps y to x. That's why we have x again. Now the second one, inverse f y is y. So what does this imply? It implies that the inverse f maps y to x, and f maps back x to y. That's why we have y again. Okay, and we can use the horizontal line test to show that a function is one-to-one. So these are the concepts of the composite and inverse function that students must know and be able to use to solve problems. Okay. Oh, sorry, I forgot. Graph of inverse function. Okay. It's simple to sketch the graph of inverse function, but you must know how to sketch the function first. Okay, consider the function here, y equal f of x, that cuts the y-axis at 0a. So to draw or to graph the inverse function, you reflect, okay, the graph of y f of x about the line y equal x. So when you reflect, 0a becomes a0. Thus, we can conclude that the graph f and inverse f are symmetrical about the straight line y equal x. Okay, let's do the first example. So those of you who have the question, okay, this is an easy question. Okay, find the composite function of g of f and state its domain. Sketch the graph of g of f and state its domain. Okay, let's look at this solution. So we have f, we have g. So g of f just now, what does it mean? We substitute f of x into g. So what is f of x? F of x is square root x minus 4. And we substitute x in g as square root x minus 4. Therefore, g of x is such that x maps to 1 over square root x minus 4. Okay, my habit is, students, I love to give the answer as what, the same form as what given in the question. Kita ikut bentuk dia. Okay, ini bentuk function notation, so we have to follow the notation form. Now, to state its domain, notice that function f has a domain restriction, x greater equal 4. And similarly here, 1 over square root x minus 4, it has also a restriction. In other words, the denominator cannot be 0. So to find the domain of g of f, okay, we have to find the range of values of x that satisfy these two restrictions. Kita ada dua restriction. First, just now x greater equal 4, and here is a fraction. The denominator cannot be 0, hence x must be greater than 4. So we have to find the common values of range of x that satisfy these two restrictions. So domain f is x greater equal 4, intersect with x greater than 4. So obviously, when you intersect one a bigger one, one a smaller one, the intersection will give you the smaller range values of x. Okay, so from here, notice that, or you can use the interval form. Notice that 4 is a round bracket, means that 4 is not included. Okay, so now you understand why this situation arises. Domain of GF lies in domain F. Okay, it does not equal DF, it just lies in domain DF because of the restrictions of the function. Okay. Okay, to now sketch the graph is easy. Let's consider first the graph of square root x minus 4. Okay, we're going to use the relationship between f of x and 1 over f of x. Okay, if you look at this curve cuts the x-axis at x equal 4. And notice that when x tends to infinity, your y tends to infinity. When x tends to 4 plus, your y tends to 0. But when you inverse it, because this is a reciprocal function, when you inverse it, okay, the point x equal 4 becomes the asymptote. And as x tends to infinity, your y tends to 0. Terbalik ya. And when x tends to 4 plus, your y tends to infinity. So this is the shape of g of f. So what is the range? Anybody can tell me the range? Remember last 2 weeks we did this? Identify the range from the curve. Okay, right. So the range will be, okay, the y values. Notice that it's stretched from 0 to infinity, but 0 is not included. So range of g of f is just y greater than 0, or you can use the interval form 0 to infinity. So here again shows that range of gf only lies in range of g. Okay, thank you, Khairul. Yes, y greater than 0. Very good, Khairul. At least you remember last 2 weeks lesson. Okay, next. Okay, number 2. Yeah, thank you, Shamirul. Well done, well done. Okay, we have f of x ln x minus 1, where x greater than 1, gx square root x minus 2, which is x greater equal 2. So find g of f and state its domain and range. Now, you are given a function, a composite function, square root ln x minus 1 minus 2 as a composition. So you need to express this function as a composition of functions which involves f and g. Okay. Okay, let's look. F of g again. This is f of g, not g of f. F of g means you substitute gx into f. So what is your gx? Square root x minus 2. Now we substitute into f of x. The x in f of x becomes square root x minus 2. Thus, your f of gx. Okay, notice that now I'm using the formula notation because in the question is given in formula form. Okay. Anyway, the three merger, but it's just my habit. Just follow what form is given in the question. Now, to find the domain, because of f of g of x, okay, look at ln square root x minus 2 minus 1. We know that it has a domain restriction. The expression here cannot be 0. Okay, so we have to find the range of values of x that satisfy these two restrictions. Okay, first, the domain of g is x greater equal to, intersect with x greater 3. Okay, so now x greater equal to intersect x greater 3. So what is the intersection? X greater equal to is the restriction for domain G. X greater 3 is actually the restriction for square root x minus 2 minus 1 must be greater than 0. Okay, we solve this, square root x minus 2, we bring 1 on the right side. So we square it, x minus 2 greater than 1, so we have x greater than 3, okay? This is the restriction for this function, ln square root x minus 2 minus 1. We know that if you look at my previous note, for ln, the value inside here must always be greater than 0. But we need to find domain f of g that satisfy these two restrictions, domain g and this function. So, okay, good, Khairul. Yes, is x greater equal 3. So again, here is a good example where the domain of FG lies in domain G. So we can make a conclusion here. When there's two restrictions, you have to use this method to identify or to conclude domain of the composite function. So what is the range? I already gave you the answer. So the range is for all y in R. Okay, for all y in R. Okay, if you don't want to use the relationship between domain of a range of FG, we can always look at the function ln square root x minus 2 minus 1. Now for ln is always, the range is always in R. Okay, but it's actually same as the range of f because both is ln. Okay, so here is from negative infinity to indicate R. Okay, so up to you. You have to decide, but choose one method, either set form or interval form. Okay. Now, second part actually is redundant, tapi tak apalah. I just want to test whether you can get the composite function for square root ln x minus 1 minus 2. Okay, can anybody write down the answer? Excuse me, because I have a sore throat, I need to drink.
Okay, come on student, can try
Yes.
it first.
So, anybody would like to give, just now we have G of F, right? So, you can guess what's the composition of function. What do you think?
Okay, we have one answer there.
Inverse F? Really? Okay, let's look. Tak apa, Khairul, good try. Let's look. Okay, we have square root ln x minus 1 minus 2. Never mind, Khairul, let's try. Okay, ln x minus 1. Do you see anything familiar? On top is f of x. So f of x minus 2. So square root f of x minus 2. Does this ring a bell? Square root f of x minus 2. So this is square root x minus 2. So your x becomes f of x. So in other words, f of x is substituted in G. Yeah, kita substitute f of x in G. Hence, the composite function is G of fx. Okay, so G of fx is square root ln x minus 1 minus 2. Okay, actually I already, this is B, typo error. Actually, it's a few questions I potong. Okay, so this is just to test you. It's a quiz actually, whether you can identify the composition of this function by looking at the composite function itself. Okay, good. Anyway, good try, Mubak Khairul. Okay, next. Number 3. Okay. Determine the function G such that G of f is negative 2 ln x plus 1. For all x in R, x greater than negative 1. Okay, you are given f of x, you are given the composite G of f, you need to find G. And later find f of G, give a reason why it is not a function. And then find a possible domain of G such that f of G is a function. Okay, let's look. Okay, to determine the function of G, okay, we are given f of x here. Okay, this is the domain. G of fx. Can I just say gf? Gfx, its domain is x greater than negative 1. Okay, good. Shamirul has already given me the step. Shamirul has already given me the step. Thank you. Okay, so we start off by writing this. Okay, Gfx is negative 2 ln x plus 1. Okay, so f of x, substitute f of x, we have x plus 1 the whole thing squared. Now, we can use the laws of logarithm of power. We bring the 2 on top, okay, negative ln x plus 1, 2. Okay, the concept mentioned by Shamiro is correct, but we use a simple method. Okay, we let x plus 1 squared equal u. Because when you express x in terms of u, you are actually finding the inverse f x. Okay, you are actually finding the inverse F. Good. So we are lucky here because the expression given is simple. Because on the right hand side, we see x plus 1 squared. So we do not have to write x in terms of u. We can straight away substitute this as u, and negative ln x plus 1 squared is u. But remember, since the function is the function derived must be in terms of x, thus gx is negative ln x. And we know that ln x, we must satisfy the domain restriction. X cannot be negative, so x must always be positive. Okay, good, Roslat. Shamirul Amin. Okay, so this is the concept used behind this step. Okay, x plus 1 squared equal u. In fact, I have done the step, but it's going to be very lengthy and I think that since time constraints, so we just choose this method because this is one of the simplest method. Okay, now notice that here is x greater than 0. Okay, that is the domain of G. Okay, this is the domain of G. Right, next. Find f of G and give a reason why it is not a function. Okay, I think most of you have found f of G. F of G means you substitute gx in f. So your gx is negative ln x. So substitute negative ln x in f, your x becomes negative ln x. Okay, my habit is I love to put the positive value in front because it's easy to read. 1 minus ln x, the whole thing squared. So f of G is 1 minus ln x, the whole thing squared. So why it is not a function? Can anybody give me a reason? Just write down the reason why it is not a function. Remember earlier I said the existence of composite function. So why is it not a function? Or what must we find to show that it's not a function? Apa perlu kita cari to show that it's not a function? Remember, just now I mentioned g of f, the existence is that, yeah. What is the condition for it is not a function? Okay, let me rephrase my question. What is the condition for the existence of a composite function? Domain F is, okay, I think it's difficult to write subset. Okay, domain F is not a subset or equal set with range of G. Okay, let's see. Okay, let's check, Khairul. Okay, range of G, do you know how to get the range of G? From the function, you can picture the negative ln x macam mana, okay? Anyway, it's ln, so ln, the range is always the real number, okay? Negative infinity to infinity. So domain of f, okay, is negative 1 to infinity. So obviously, the range of G is not in domain f. Okay, for those who have difficulty in visualizing, let's draw the number line. So this is the range of G starting from negative infinity to infinity, meaning that range of G is very wide. The values of x is very wide. But the domain of f starts from negative 1 but does not include negative 1. So clearly here, domain of f is inside range of G. It's supposed to be range of G must be inside domain f. Hence, since range of G is not a subset or equal set to domain f, f of G is not a function. Okay, this is a favorite question. Either they ask you to say why it's not a function or prove that it is a function. Diorang suka tanya tu, okay? Right. So now we need to find the possible domain. So meaning that we have to restrict the domain of G so that f of G is a function. Okay, we need to restrict the domain of G so that f of G is a function. So remember just now, if f of G exists, the range of G must be a subset or equal set to domain f. Okay, now how can we find the set of values of x so that range of G is a subset or equal set to domain f? So now, range of G, what is range of G? Gx. Okay, gx is negative ln x is the range of g. Now, why do I equate to negative 1? Because we must put the range of g in negative, as in domain f. So domain f is x greater than negative 1. Tu je. Okay, look at the domain of f, look at the range of g, and then we solve it. So multiplying by negative 1, both sides, your inequality changes direction. Okay, now ln is log base e. E is a number which is greater than 1. Okay, so x is still, okay, the interval maintained less than because e is a number more than 1. So we have x less than e. Okay, we convert this into exponential form, e to the power of 1. Okay, now is this the final answer? All of you agreed this is the final answer? Yes or no? X less than E. Because they ask a possible domain of G. So is X less than E the final answer for the domain? Or we have to do something else? We check ln X. Oh no, thank you Syafiq. Okay, thank you Cikgu Syafiq. Okay, so we have to do, notice that ln X, okay, for X to be defined, your X must be greater than 0. So we must find the values of X that satisfy these two conditions, okay? So we have X 0 and E. So this is the number line that represent X less than E. And this is the number line that represent X greater than 0, okay? The unshaded circle means it's not included. So the range of values of X is where the two lines intersect, okay? So where does these two lines intersect? Okay, from 0 to E. So the possible domain of G is 0, X between 0 and E, or in notation form, interval notation form is just 0, E. Okay, good, Syamirul. So all the pandai, all the students today are very good. Okay, it make me excited. Okay, now, so now our G has restricted, okay, the domain has become X between 0 and E, okay, in order f of G to exist. Okay, let's check. Dia tak tanya, I'm just showing you. We can check by sketching the graph of Gx in the domain 0 to E. So this is the graph of negative ln X from 0 to E. Okay, X equals 0 is the asymptote. Notice that the range of G is from negative 1 to infinity, and domain of f is negative 1 to infinity. They are the same. So here f of G exists because the range of G is equivalent to domain f. Okay, equal set to domain f. Right. Well done, students. All of you understand? Okay, now.
Okay, Teacher Zana,
Yes.
would you like to take a break now and let the student absorb all the information that we discussed just now?
Yes. Okay, we can do question 4.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay.
Okay, welcome back students. Before I give this session to Teacher Zana to continue, okay, I will announce the second and third digit code at once for credit claim. So listen carefully. The digit is 25. Two numbers. 2, 5. Okay.
Followed by 5. Okay, number 2 followed by number 5. Okay.
Okay, Teacher
Right.
Zana, you may proceed.
Okay, thank you, Madam Rosmaya. Okay, number 4, we have f of x, exponential function e to the power of 2x minus 3, and its composite f of g is 3x. Okay, so find g and state its domain, sketch the graph of g, show that g of f exists, find g of f and state its domain. Find the exact value of p such that g of fp is ln square root 3 over 2. Okay, so this is actually a passive question, section B. So find g. We are given f of x and f of g. So let's look here. This is simple because gx is substituted in f of x. So when you substitute gx into f of x, we have 2 e to the power of 2 gx minus 3, equivalent to 3x. Now taking ln on both sides, ln e to the power of 2 gx minus 3 is just 2 gx minus 3. Okay. And here becomes ln 3x. The next step is just simplifying to make gx as the subject matter. So now, when you identify the function g, you have to state its domain. So what is the domain for g here? This is ln 3x. In order for g to be defined, domain must be x greater than 0, because there is no domain restriction for this function f of x. It's for all x in R. So here only gx has a domain restriction because for ln, the value 3x must be greater than 0. Thus, x is greater than 0. Or we can put R plus, the same as f of g. Okay, because there is no domain restriction for f of x. Similarly, f of gx is just 3x. Okay. R plus means x greater than 0, okay? All right. Next, sketch the graph of g. Okay, this is actually 3 over 2 plus half ln 3x. Okay. So ln 3x, half ln 3x, okay. For ln, it's very easy to remember the shape of logarithmic curve. It's always this shape. Okay, it's always this shape. Only that you have to find the point where it cuts the x-axis. Okay, if we translate, okay, 3 over 2 is still the same because the main point is here, where it cuts the x-axis. So the working here is you equate gx to 0 because when it cuts the x-axis, gx is 0. So simplifying, ln 3x is negative 3. So 3x is e to the power negative 3. You convert ln into exponential form. Hence your x is 1 over 3 e to the power negative 3, which is 1 over 3 e to the power 3. So this is the graph of gx, the sketch graph of gx. So tu je kan dia minta kan? Yes. Okay, now remember just now the sketch graph of gx. Let me check because there'll be a question. Show that g of f exists and find g of f and state its domain. So we have g just now. Show that g of f exists. Okay, by now all of you should know, in order for g of f to exist, the range of f must be a subset or equal set to domain f, domain g, domain g. The range of f must be equal set or subset to domain G. Remember that, yeah? Okay. So range of f just now is from 0 to infinity. Faham ni macam mana dapat 0 to infinity? Because this is exponential curve. Exponential curve e to the power of 2x cannot be, it's always positive, it cannot be 0. So the range must start from 0 to infinity. If you remember the exponential curve, it's always above x equal 0. Hence, the range of f starts from 0 to infinity, okay? Not inclusive of 0. Domain G here starts from 0 to infinity. Thus, we see that the range of f is equal set to domain G. Since the range of f is equal to domain G, thus G of f exists. So by now, students, hopefully you can visualize all the shape of the curve so that you can identify the range easily, okay? And the domain senang because domain is given in the function. The range, you have to visualize the curve in order to get the range. So you already show that G of f exists. Okay, so the rest, find G of f. So substitute f of x in G. F of x is this, e to the power 2x minus 3. Okay, 3 plus ln, 3 times e to the power 2x minus 3 over 2. Okay, this is 3 times. I purposely say 3 times or multiply. Why? Because we need to apply the logarithmic laws of product. So this is ln 3 plus ln e to the power 2x minus 3. Now this is ln means log base e. Log base e 2x minus 3 is just 2x minus 3. So simplify, you have 2x plus ln 3 over 2. Okay. Would anybody like to state the domain of GF? This is GF. So what is the domain? So mereka kata state, yeah? And this is X. There's no domain restriction here. Ln 3 is a number. It's a value. Ln 3 over 2 is a value. The only X is just 2X here. Or you can simplify. G of fx is x plus half ln 3. Half ln 3 is a value. So anybody would like to state the domain for all x in? This is G of f. So domain G of f must be the same as domain G of f must be the same as, what is it? Domain f, okay? It must be the same as domain f. So domain f is R. Okay? Because there's no domain restriction involved in f, be it in f and also G of f. Okay? There's no domain restriction. So this function is defined for all x in R. Okay? Okay, this one is simple. Just substitute P into G of f. Okay, just substitute P. So we have P plus half ln 3 ln square root minus ln 2, applying the logarithmic law of quotient. Okay, ln square root 3 is just half ln 3. So half ln 3, half ln 3 cancel off. So your P is negative ln 2. Okay. Right, so that is for number 4. Okay, number 5 involves inverse function. Show that f has an inverse. Find the inverse of f, state its domain and range. Find the function inverse f minus function g. Okay, we are subtracting the inverse of f with g and determine its domain. Okay, to find the inverse, we have to show that it's 1-to-1. So the most easiest method is to sketch the curve. So this is exponential curve. Okay, we know that e to the power negative x is always greater than 0. And so we need to translate the asymptote y equals 0 to y equal 1. And when it cuts the curve, it cuts at y equal 2. Okay. So now we have to show that a horizontal line cuts the curve at only one point. Okay. Okay, it can be on top. Cikgu nak tanya Max D dengan Max M sama tak? Sama. For this topic, it's the same. Okay. Anaki, Haziq is the same. Max D and Max M is the same. So you have to know this definition to show that it's f1-to-1, you do the horizontal line curve. So, and you have to make a conclusion. Since all the horizontal line cuts the curve at only one point, so f is a 1-to-1 function. So this is called the horizontal line test. So f of 1 exists, okay? Now we need to find f inverse. So I always tell my students, remember the definition of inverse function. So let inverse fx be y, so fy is x. So you substitute y into f, so everything here becomes e to the negative y plus 1. Okay, then e to the negative y is x minus 1, taking ln on both sides. We have negative y equal ln x minus 1. Okay, as I said, this must be positive, y equals negative ln x minus 1. So your inverse function of f is negative ln x minus 1. Right? Sampai bab berapa cikgu? Anaki sampai first 3 chapters are the same. First 3 chapters are the same. Okay, so how to get domain of the inverse function? Remember? Okay, to get the domain of the inverse function, we have to get the range of f. So how to get the range of f? We look back at the curve that we have sketched. Okay, so the range of f is the y value. So the range of f is y greater than 1. So domain of the inverse f is x greater than 1. Remember, since it's 1 to 1, domain of f inverse is the same as range of f. So the range of the f inverse is the same as domain f. So domain f is what? X belongs in R. So your range must be in terms of y. Ingat, range is always y, domain is always x. Okay, Peggy O, what's the difference between vertical line test and horizontal line test? Vertical line test is to show that it's a function. Tu je. To show that to show that it is a function. Okay. The horizontal line test is to show that also 1 to 1 and on to actually 1 to 1 and on to. Okay. This is to show that it is 1 to 1 function. A vertical line test is just to show it's a function. Remember, function can be 1 to 1, many to 1. Betul tak? But here we only need 1 to 1 function to have an inverse. Okay, Peggy, does that answer your question? Okay, that's the difference between vertical line test to show that it is a function. So because function must have only one image, so it can be 1 to 1, many to 1 relationship. But here to have an inverse, okay, it has to have an inverse, the f must be 1 to 1. Okay, now understand this notation. Most of my students get confused the other day when it comes out in the exam. This is actually minus, so you subtract the 2 function. Okay, you subtract the 2 function. So subtract macam biasa. Okay, inverse f x minus gx. So we have negative ln x minus 1 minus negative ln x minus 3. So negative is positive. Then applying the laws of logarithmic of quotient, we have this ln x minus 1 divided by x minus 3. Now, to get the domain, okay, again, we have to find the range of values of x that satisfy the domain of the inverse and domain of G. Because domain of the inverse is for all x in R, domain of G is for all x greater than 3. So again, we do the number line. This is domain of G. 3 is not included. This is domain of F inverse. Okay, the range for the domain is represented by the intersection of 2 lines. Okay, so this is where the 2 lines intersect. So domain of F inverse minus G is for all x greater than 3. Okay, so this also applies for if you add 2 function or you multiply 2 function. But if you divide 2 function, remember the denominator cannot be 0. This question dah lama tak keluar. So once it come out, semua pelajar terperanjat. Okay, number 6. Okay, actually this question is lengthy, but actually it's simple. Okay, first we sketch the graph of f, state the corresponding range, find the domain of f. If the domain of f is restricted to values of x for which x is greater than a, so we need to find the smallest value of e so that f becomes 1 to 1, and we need to find the inverse f of x and state its range. Okay, Okay, now we look at this function is a quadratic curve minimum point. So straight away you can tell the minimum point because the function is already in completing the square form. So the minimum point is 1, 3. And it cuts the y-axis at 0, 4. Just substitute x0, we have 4. Okay, so and the range, can everybody tell me the range? We did this last 2 weeks ago. From the graph, you can tell the range. What is the range? Because this is quadratic, so the range is bounded. Anybody can tell me the range? The range is just the y value. So y greater equal 3. Okay, look at the y value. It starts from 3 onwards. Okay, this is how we identify from the curve for the range of f. If you're still unsure, you can look back at the previous live class how to identify domain and range of a function. Or you can write in interval form where this is a square bracket to show that 3 is included. Okay, now we need to find the smallest value of a. Okay, good, Shafiq. Yeah, good. Okay, we need to find the smallest value of a for which f becomes 1 to 1. Once it becomes 1 to 1, we need to find the inverse f and state its range. Okay, now if we were to draw the horizontal line, that's what happened. It cuts the curve at 2 points, hence it's not 1 to 1. So how do we make it, what must we do to the curve such that it becomes 1 to 1? So notice that this quadratic curve is symmetrical at x equal 1. So we can divide this curve into half. Okay, so we divide into half, so we are left with this part, okay, from x1 onwards. So your a is 1, okay, because see that this vertical horizontal lines, it cuts the curve at only 1 point. So f has become 1 to 1. So this is an example where you need to know how to find the restricted domain in order for f to become 1 to 1. Okay, so since x is greater equal 1, so your function now f of x has a new domain. Okay, x greater equal 1. So now f is already 1 to 1. Okay, already shown here. So again, using the definition of inverse function, hafal ni ya. This is the proper way of writing, in fact, to find inverse of f. So substitute y into f of x. Okay, the rest is just applying arithmetic manipulation. So find the square root y minus 1, square root x minus 3. So when we find the square root x minus 3, notice that we have plus minus is a value here, because this is a value. So y, okay, which value must we take? Is it 1 plus square root x minus 3 or 1 minus square root x minus 3? So we look at the range of y. So the range of y is always greater equal 1. So kamu cikgu confident sangat, because the range of the inverse is the same as domain of f. The range of the inverse is the same as the domain of f. So since y is greater equal 1, so we have to take 1 plus square root x minus 3. Okay. So the inverse, yes, good, Shamirul. So the inverse of fx is 1 plus square root x minus 3. So what is the domain of f? What is the domain of inverse f? So domain of inverse f is the same as range of f. That's why I love inverse function, because senang nak cari the domain and the range. Okay, it's just the reverse. Okay, so domain of the inverse is the range of f. The range of the inverse is the domain of f. Okay. Okay, so what is the range? The range is just the domain of f. Okay, so well done for those who have managed to try the answer the question just now. And if you get all correct, meaning that you understand the concept of inverse function. Okay, last question. We've got 5 minutes. Okay, going very fast, okay? Okay, so we have given find the inverse of f, inverse of g, state their domains, find f of g, state its domain, verify the f of g inverse is same f g inverse of f inverse. Then sketch the graph of f of g and f of g inverse on the same coordinate axis and state the range. Okay, now we are given f of x. We're going to find one by one first, okay? So again, we use the definition of inverse function, okay? So now we have y, fy is 9 minus y equal x. Remember, inverse of f is y, so we need to find y. So converting this to exponential form, 9 minus y is equivalent to e to the power of x. So your y is 9 minus e to the power of x. So what is y? Y is the inverse of f. Okay, now, so what is the domain? The domain of inverse is the range of f. Domain of the inverse is the range of f. This is ln 9 minus x. So what do you think is the range of f? Ln 9 minus x. For ln, the range is always r. Ln. Remember the shape of the curve just now? So it's always the real number system. R, it can take any values in the real number system. So domain of the inverse is the range of f, which is x in R. Ingat ni, ln, the range is always R. Okay, and domain of the inverse is the same. Okay, good. X greater than 0, no. We follow this rule. For inverse, you have to follow this rule, Shamirul. Domain of the inverse, yes, R. Khairul, that's right. Domain of the inverse is R. We have to follow this rule for inverse function because it's 1-to-1 and onto. Okay, and okay. Now find the inverse of G. Again, we use the definition of inverse like G inverse by. So Gy is x. So substitute y into G. So you have this. Okay, now it's a little bit tedious but not difficult. We're going to change this into computing the square form. Okay, so how do you do computing the square form? Okay, y minus 3 squared minus negative b over 2a squared, right? So if we have negative b, negative 6 over 2 is negative 3 squared. So if you have forgotten, please look back at form 5 or form 4 function, okay, to convert into computing the square form. So we have y minus 3 squared is 9 minus x. So again, we have to find the square root of 9 minus x. So we have plus minus. So when you bring 3 to the other side, so we have 3 plus minus square root 9 minus x. So again, we choose plus. Why? Look at the domain. The domain is the range of the inverse. The domain is the range of the inverse. So for y greater than 3, okay, y is always greater than 3. Sorry, the range of the G inverse is y greater than 3. So this must be plus. Faham ya? Because y must always be greater than 3. So you have to choose plus. So we have the inverse of gx is 3 plus square root 9 minus x. So what is the domain of the inverse G? What is the domain of inverse G? We know that range of G is y less than 9 because this is 6x minus x squared. Okay, the maximum point is 3, 9. Okay, so the range of G is for y less than 9. Or you can sketch the curve, see the maximum point. The maximum point, or from here you can tell, because from here you can tell the maximum point is 3, 9. So the boundary is 9. Okay, so the boundary for the range of G is 9. It's from negative infinity to 9. So domain of the inverse G is the same as the range of G. So domain of the inverse G is for all x less than 9. So we follow this rule. Okay, domain of inverse G is the same as range of G. So all you need to do is find the range of G. How? By looking at this computing the square form. We know there is a maximum curve. So remember last 2 weeks I mentioned to find the range, we have a boundary. The boundary is the maximum point. So from negative infinity to the maximum point. So the maximum point is 3, 9. So y must always be less than 9. Okay? Boleh ya? Good, Khairul. Okay, now find f of g. Okay, this is very simple. Substitute g into f. Okay, so ln 9 minus x, your x is gx, yeah? Your x has become gx, so 6x minus x squared. Simplifying, x squared minus 6x plus 9. This is ln, yeah? Ln x squared minus 6x plus 9. Okay, you can factorize this. Okay, it's ln x minus 3 squared because we have to write our answer as simplified as possible. So we can use the laws of logarithm for power. So you can bring down 2. So f of g is just 2 ln x minus 3. Now, what is the domain? This is composite. Domain of f of g is the same as ke. Here gx no restriction. Yes. Domain of f of g. Remember, kalau tak tengok pun the rule pun tak apa, just tengok sini je. Look at this. Ln x minus 3 here cannot be 0. For ln, the number of value here cannot be 0. So x minus 3 must be greater than 0, x greater than 3. So domain of f of g is the same as domain of g. I did mention just now, there's no restriction here. Okay, tak apalah, it's good try, Muhammad Khairul. Domain of f of g is always the first function is the same as domain g. Ingat, domain f of g either the same or lies in domain of g. If same means there's no restriction in the domain of g. Okay? Faham ya, Khairul? I think you need to do more exercise, Khairul. Sometimes cikgu pun boleh get confused too. Alright, so now verify that f of g inverse is the same. So we find, okay, I already given you all this function here, f of g, inverse f, inverse g, okay? So f of gx, let f of g inverse be y, hence f of gy is x. So what is f of gy? Just substitute x as y, 2 ln y minus 3 is x. So ln y minus 3 is x over 2. Hence, y minus 3 is e to the power x over 2. Thus, your y is 3 plus e to the power of x minus 2. So, what is y? Y is the inverse of f of g. So, for all x in R. Okay, remember? Domain of the inverse f of g is the same as range of f of g. Range of f of g is R. The range of f of g is R because this is ln. It can take positive and negative value for all x greater than 3. Okay. This is inverse, yeah? Okay. Next, we have to show that we have to show that the composite of g inverse f inverse is the same. So first, okay, substitute the f inverse into g inverse. Your f inverse is 9 minus ex. Substitute into g inverse. So your x becomes 9 minus ex here. And then we simplify. 9 minus 9 is 0. Negative, negative is positive. Now square root ex is actually e to the power of x over 2. So, but then to verify that they are equal, you must state the domain too. So domain of the function, the composite function g inverse f inverse is for all x in R. Remember, this is the same as this. Domain of g inverse f inverse is the same as domain of f inverse. Now we are not looking at the inverse, we are looking as a composite function. So when they are equal when the domain are the same. So hence we can conclude that the inverse of f of g is the same as the composite of g inverse of f inverse. Okay, this is actually a rule, but this rule is seldom being used. Okay, right. Okay, senang saja ni. Most of the students, this is actually Maths M past year question, and the marking is quite lenient, whereby most students, okay, does not indicate the domain, they get marks. Okay, they get marks if they do not indicate the domain. Okay, but the proper way of proving is that they have to show that the domain must also be equal in order to show that these functions are equal. Okay, sketch. Okay, the last one, sketch. Okay, okay, this is the function f of gx, 2 ln x minus 3 for all x greater than 3, and this is the inverse of f of g, 3 plus e of x over 2 for all x in R. So all you need to do is just sketch this curve, f of g. Ln, okay, x equal 3 is the asymptote because x must be greater than 3. Okay, as I mentioned earlier, okay, the shape of ln is always the same. This is the shape, but you only need to find where it cuts the x-axis. So it cuts at x equal 4 because 2 ln 1 is 0. Now, to sketch the inverse, okay, draw the line y equal x because the inverse of f of g is the reflection of the curve f of g. So you reflect this curve f of g about the line y equal x, we have this. So you have to reflect the asymptote too. You have to reflect 4, 0 becomes 0, 4. So notice that this is an exponential function, 3 plus e to the power x over 2. This is the shape of the exponential curve. Okay, it will never touch y equal 3. Meaning that we have translate the exponential function 3 units above. So just remember, I always tell my students, it's simple to sketch the curve of the inverse function. You just reflect the curve of the function at the line or about the line y equal x. Now, the last question, can anybody state their range? So what is the range for f of g? Last 2 questions. So can anybody state their range? This is f of g. Okay. So to get the range, you look at the curve. We have negative value, we have positive value. So the range of f of g is, yes, that is for the inverse of f of g. Okay, R. Yeah, betul, Cairo. The range of f of g is R. This is f of g, yeah? And the range for the inverse, bau Syamirul betul, y greater than 3, okay? Muhammad Nur Badlish, ya. All values of y. Okay, boleh lah, in R. All values of y in R. Okay, in R. Range f of g. Here, range of the inverse is for all y greater than 3. Betul lah, Syamirul? Okay, y greater than 3 for the inverse f of g. Okay? This is a passive question. If you have managed to answer it well, meaning that you can already sit for the Stpm exam. Okay, that's about all for today. I'm sorry, sekiranya I'm going very fast, and today I'm not feeling well. I just found out that I have this RA syndrome. RA, you check lah, rheumatic arthritis, whereby I have difficulties in typing. Tangan sakit. Anyway, thank you for joining my class. You have been superb for answering my question. I really enjoyed it. Okay, ya betul Syamirul. Dia nak dua-dua sekali range. Bagus. Okay, so before I end, do not forget to subscribe to my channel and also to the rest of my colleagues here, Teacher Im, Cikgu Fatia, and Madam Usmaya. But before I leave, I would like to say Happy Merdeka Day, which fall on 31st of August. Okay, that's all about all. So I give over again back to Madam Usmaya. Okay, thank you, students. Okay, Madam Rusmaya, it's all yours now.
Okay, with God grace, we have reached the end of today's session. Congratulations to those who are able to follow our session from the beginning till the end. Before we end our session for today, I will announce the last digit code for credit claim. So the digit is 0. Okay, I repeat, the digit is 0. Okay, so all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, please do so. Make sure it turns to a grey color, okay, not the red color. And activate the icon bell so that you will not miss the next session, the next class session. Then if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness.
Madam Rusmaya, Taufik Hidayat tanya last code. Last code. Dia tak dengar kot.
Yeah, okay, you didn't hear just now, right? Yeah. Okay, never mind lah. I repeat, the last code, okay? The last code is 0. Remember, the last code is 0. Okay, so once completed, you type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, so the link for the certificate and the link to claim credit are already given in the chat box. Okay, so please take note, the link will end half an hour after this live. Okay, make sure to use the EDD email only to log in. Incorrect email used will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. Okay, so if you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. Okay, so once again, I would like to thank all of the students for joining today. Remember that the more classes you join, the more credit you can claim. Yes. So feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students. Thank you too for being a YouTuber Academy supporter too. Okay, so I think that's all for now. See you in another session. Ingat hashtag bermula percuma, selamanya percuma. Okay, Assalamualaikum. Stay safe. Till we meet again next week, same day, same time on Saturday at 5 p.m. Okay, bye-bye.
Bye-bye.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia, langkah laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Misi kita, bantu kita, bermotor sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. Akademi YouTuber Malaysia, berpadu bersatu keluarga ayu, memberi ilmu tanpa jemu, siap sedia menyumbang ilmu. Ilmu diberi juga dikongsi pada semua generasi yang terkini. Lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi YouTuber Malaysia, langkah laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Misi kita, bantu kita, bermotor sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU. Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Bermisi kita, bantu kita, bermotor sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.